Hi, I am Enrique Aguilar from La Salle Bajío University in Mexico, formerly a Microsoft MVP and Xamarin MVP. And today I'm going to show how to integrate the Python code that includes some basic AI model with PyTorch into a Blazor Web application using C#.NET. This is the agenda for today. First, we'll look at the benefits of the integration, then the step involved, followed by a basic demo. After that, we'll move on to demo 2, which include AI, and finally the conclusion. Don't worry about the code. It will be available on GitHub for the. Why not use Python and C# at the same time in the same application? C# has a strong support in the business world. Many people know how to program in C#. It's very fast with a modern JITs and optimized garbage collector. Performance is one of C# strengths. Python, on the other hand, is extremely popular. It's the #1 language in adoption, usage, and repository activity. Python has a massive ecosystem of libraries and is the favorite in data science. Attempting to port hundreds of thousands of Python libraries to .NET will be a monumental challenge. Python shines in data science, machine learning, and AI. There's a rich ecosystem of scientific libraries that researchers use for experimentation, analysis, and visualization. More people are learning Python in universities, and more research is being done in Python. So, with the AI boom, Python continues to lead. On the .NET side, we have a strong presence in enterprises, powerful IDEs, Visual Studio, Code, Writer, cross-platform capabilities, and massive performance leap from .NET 6 to 10. .NET is a high-performance environment with a garbage collector that improves every year. With Blazor, minimal APIs, and .NET MAUI, we have a very mature ecosystem. Now, for that, we have CSnake, a NuGet package that allows us to integrate Python code in C# application. The goal of CSnake is exactly that, to take something from the Python ecosystem, add it on to .NET app, and enhance it. There are mature libraries in Python that .NET still doesn't have. How does CSnakes work? It embeds the Python interpreter with the .NET process. C# is a NuGet package you add to your .NET project. You drag in your Python file, and at runtime, it embeds the native Python engine, fully compatible with any current Python library. Full integration without leaving your IDE. What do we need? A Python code registering the service in program CS and the C# code to instantiate the Python code. And that's it. Don't forget to install the NuGet package CSnake runtime. Go to demo 1. Here we add the NuGet package, in this case to a Blazor Server application, and set a property in the project to point of the Python files included in the project. This is in properties, right? And properties are the project. Then, in program CS, we create an instance to load the Python file, and the services we'll be using, as well as the Python version to use. Next, we set up the Python environment, In here case, we'd use the path combine, environment, current directory, the services we'll be using, as a Python version to use. Okay, next we set up the Python environment. Now let's move on the Python file and method that adds two numbers. We create a file named demo and specify the Python version to use. In configure Python interface, interpreter. Here, and now Python 3. Okay, now let's go to our home Blazor file in the Blazor application. Using CSnakes runtime, we inject the Python environment for usage. Okay. The render mode, interactive server. Okay, set up the UI elements to receive input values and add a button to trigger the process and display the result, right, using HTML code. First number, the label, and input. Bind, input A, input B. Button on click. If result has value, result. Now on the C# code, we declare our variables and define the method that's triggered by the button. We create an instance and pass the value received from the UI. Private double input A and B and result. Private void from reference by button. instant to demo that this is the code, the Python code, and the method add. In this side, input A and input B, and result print of the screen of the user. Here I've downgraded to version 1035 of CSnakes, which is more stable. We compile and run the app. Okay. Enter the values, and that's it. We have a Blazor Web Application in C# that interacts with a Python code. Okay? All right. Now let's move on the second demo, which include a basic AI integration. First, we load a question answering model from the transformer library. We define the context, in this case a paragraph about the solar system. Then when a question is asked, the application analyzes the paragraph and evaluates the best answer based on the model confidence. It returns the result accordingly. If it's unsure, it responds that it doesn't have enough information. The requirements for this demo include defining the Python app dependencies in the requirement file text, PyTorch version 2 or higher, transformer version 434. Okay, the Python code. See, some natural language processing libraries like Tokenizer by default try to use many threads and parallels, which can sometimes trigger warning message or consume unnecessary resources. And this line tells the program not to do that. Torch, the core library of PyTorch, which is the framework used to load and run the AI model. Pipeline, a function from the transformer library that simplified tasks like question answering. Typing, used mainly to define data types, mostly to make the code clearer. And context. Context is a list of English paragraphs describing factual information, in this case about the solar system. When the bot receives a question, it will search through each of these paragraphs to find the most reliable answer. This code limits the number of PyTorch threads to avoid excessive memory usage. Load a pre-trained model, Roberta-based Squad 2, and its tokenizer, but specially for the question answering task. Device -1 forces the model to run on the CPU instead of the GPU. Input question, the user question, paragraph on the context paragraph, and output the answer and score. The score measures how confident the model is that the answer is correct with that paragraph. Okay. The next code is initialization. If the model has been loaded yet, call initialize. Prepare the question, search for the best answer. If the best score is very low, or there's no answer, return an apology message. Otherwise, return to the most confident answer. Now the code, the Blazor, the C# code, and the Blazor interface. We add the CSnakes library, the Python environment, and text box with a button. In the code, we define the event that triggers when the user clicks the button. In that method, we call the Python environment and display the result in the UI. Don't forget to configure the project properties to ensure the Python files in the directory are included. Okay, demo 2. All right. Here we have the Python code. The context, see, here the context, okay, the Python code. Next, the requirements, PyTorch, for example, and the C# code. Okay, run. So we type in the prompt how many planets orbit the sun. Hit send and give us the result, 8. We keep asking question and continuous returning the corresponding answer. What bodies make up the solar system? Sorry, I don't have enough information to answer that. What type of the star is the sun? G2b. Which planet is closest to the sun? Mercury. When it can find the answer, it returns an error and continues searching for the best possible response based on our context. Another question. At thin carbon dioxide atmosphere. With the setup, we can use our Python application and deploy them without needing APIs, directly with the same development IDE. In this case, Rider on Mac, but it works the same in Visual Studio or Visual Studio Code. Conclusions. Combining technology expands the developers' capabilities, allowing them to enhance their projects by integrating different programming language. It makes it easier for Python developers to access the advantage of .NET technology. It also helps .NET developers get closer to data science and AI technologies available in Python and its libraries. Python provides a competitive advantage to .NET developers by bringing them closer to the world of the data science, machine learning, and AI. C# provides a competitive advantage to Python developers by giving them access to the cross-platform .NET ecosystem, including Blazor, .NET MAUI, Minipal APIs, and more. Thank you very much for your valuable time in this session. I'm sharing my contact information on LinkedIn and X Twitter, as well as the GitHub repository, so you can download the project and start integrating your Python code in .NET. See you next time. Greetings from León, Guanajuato, Mexico. See you.